Hello, everyone. Actually, today is my first time to talk about my area of study to someone who is in the different area. So I really thought about what I should talk, and I decided to talk about the overview of the sports injury prevention research because I just want to introduce what kind of things are involved in this kind of research. Okay, the outline. First, I'm going to introduce several kinds of injury prevention research, related to research. And then I'm going to talk about what we do in our research lab. Okay. And then first, what is sports injuries? Sports injuries, injuries that often occur during athletic activities. And the example is like anterior cruciate ligament injuries and patellofemoral pain syndrome, ankle sprains, shoulder dislocations, and so many other things. And I am going to talk about the framework of injury prevention related to research using the example of anterior cruciate ligament injuries preventions. It's because this is my, the focus of my research. So. Okay, then why anterior cruciate ligament injuries? Because there are so many injuries occurring in the United States and also all over the world, and also in my school too. And in my school, we usually evaluate more than 20 ACL, reconstructed athletes every year, and this is the largest, patients that we have. As compared to other injuries. And also interestingly, more than 70% is non-contact injuries in nature. And non-contact ACL injury, non-contact injury means when you get injury, you don't receive any external force other than ground direction force. The shock from the ground. And also, ACL injury mostly happen during a sudden deceleration phase, such as landing or cutting motions. And the other interesting thing is ACL injury rate in females are 2 to 8 times higher than males. And also, it takes very long time to return to play. And it is a really serious concern in basketball and handball because these sports involve a lot of deceleration, acceleration motions, so they have a lot of ACL injuries, right? So, and there is probably about PubMed. This is the literature search for biomedical and life science journal literature, and today I did literature search using this one, and I put keyword ACL, and I hit 7,750 hits and ACL plus injury, and I got these numbers. So many people are interested in ACL injuries for their research. And this is just video of how they get injured. And now, yeah. And this is another one. And yeah, just look at this lady. Yeah, now she got injured. And this is another one. And this is the last video. Sorry what you're eating. Now, her knee got injured somehow. So then we are talking about the ligament. This is femur, and this is tibia. And this ligament is the anterior cruciate ligament, or ACL. and this ligament is somehow got injured. So if we really want to prevent sports injuries, I think we have to think about so many things, like mechanism of injuries, and also movement, the neuromuscular strategies or techniques to reduce unnecessary stress to the tissue. And this is based on the mechanism of injuries. So, and also epidemiological information and anthropometric and body structural information, physiological information such as like hormone and those kind of things, and the environmental information, surface and shoes and those kind of things, and the physical information and biological information, and nutritional information, training science, and tradition of the sports. So many other things. So it is really, hard to think about, how to prevent injuries. So the purpose of the injury prevention research is to organize, this information, scientifically, so that we can effectively intervene people to prevent their sports injuries. Then what is the biggest limitation in the sports prevention injuries prevention research? So what do you think? What is the biggest limitations? And I think to think about this one, I think we have to think about what is the most important information for sports injury prevention. So is anyone can answer this?
Willingly injured athletes.
Yeah, that's right. Actually, that's one thing. Actually, that's the thing. So we cannot get biomechanical data when the the real injury actually happens. So in order to understand the mechanism, we have to know all the internal and external forces, and also all bone motions during actual injuries. So it is really difficult to put somebody in the lab and make them get injured and get all the muscle force, ligament force, and the contact force, those kind of informations. Yeah, probably it's impossible, at least in the United States, and all, So, but we have major research topics in ACL injury prevention related to research. One is the research that examining ACL injury mechanism or loadings. That like Eric is doing this kind of research lots of times. And also another one is intervention research to reduce ACL injury risks or rates. And also research investigating mechanisms for how ACL injury may be prevented. So this is more talking about how this intervention leads to some change in neuromechanics or those kind of things, and that leads to injuries, those kind of things. And also research to clarify how ACL injury risk factors may contribute to increase ACL injury risks. And I made this diagram to understand the overview of the injury prevention research. So if you think about the mechanism of the injury, I think we are talking about this part. What external force, what internal force, what joint angle, segment positions increase, stress on the tissue, specific tissues, and this leads to, increase in injury rates or injury risk. And you can think about the mechanism from the big area like this. So you may have some movement pattern or neuromuscular strategy or those kind of things that may lead to some bad external force, internal force, bad joint angle, and that leads to increase in risk of injuries. And also, you can think about the injury mechanism from the risk factors. For example, some risk factors such as sex hormone alignments, geometry of the bone, range of motion limitations. All of these may influence neuromuscular controls or position of the body during the movement, and that may affect external force, internal force, joint angle, those kind of things, and that influence the risk of injuries. And sometimes this kind of risk factor directly affect to the stress on the specific tissues. For example, it's like tibial slope, posterior slope that Eric was talked about in his paper. If people have some kind of risk factors, if you receive the same amount of force, you may have more stress on the tissue, and that directly influences the risk of injuries. And also, if you think about the prevention of the injury, we are thinking about this part. So if you do some intervention to risk factors, or if you intervene some neuromuscular control, or then you may go these good pathways, and may lead to reduction of injury rates. So in any way, the most important thing is this part, that this mechanism of injury part. Without this, we cannot reduce any injury. We don't know how to reduce injury. So Eric is doing really, really important studies. Okay, so there are some kinds of studies examining non-contact ACL injury mechanism. And there are several, many kinds of studies because, each studies have limitations and strengths. So we have to try many different ways. And first one is visual analysis of ACL injury scenes, or retrospective studies, and cadaver studies that Eric do. And also in vivo study, this is using living human and measuring ACL strain. And also computer simulation studies, and also systematic review, literature review, those kind of things. So people have tried to understand the mechanism of injuries. We haven't had a clear answer about this one. Mechanism of injuries. So this is the example of video analysis of anterior cruciate ligament injuries. He got injured right after the landing, and researchers examined the position of the body segments. And this is another example done by Olsen. And in this study, MD, medical doctor, and handball experts analyzed ACL injury scenes, and they determined what motion occurred during the ACL injuries. And strengths and the limitation of these studies is strengths is they analyzed, this kind of study analyzed actual ACL injury scenes, and experts analyzed motions. But limitations, nobody knows, when ACL injury occurred. You can see it, and also you cannot see actual bone motions. And there is no data about, internal or external forces applied to the knees. So this study was done by Koga et al. And they matched skeleton model to the actual injury scenes, and they try to visualize bone movements more clearly. The strengths, again, they analyzed actual ACL injury scenes, and the results are more reliable as the skeleton models were matched with actual motions. But I don't know about this. So limitation is probably accuracy and reliability. And again, the moment of ACL injuries are unknown. It is really hard to know. And again, no data for internal and external forces applied to the knees. Now, in the retrospective study, there are several kinds, and one is like reviewing medical records, and just looking at the medical records and what positions your thigh was, or those kind of things. And also interviewing ACL injured people. Then there is an example by Bowden, and they interviewed ACL injured patients about what situations and what emotions happened, when ACL injuries occurred. And strength of this study is, this information is from the ACL injured patients. So this is the real strength. And also, this study provides information about the moment of ACL injuries and the limitations, probably reliability of the information, because length of the time period from the injuries to the interview was range from 1 day to 30.3 years. So people may forget. And also, probably there are some difference between actual motions and sensed motion, especially like horizontal plane and frontal plane motions in the knee is very small, so it's really difficult to know what motion occurred, as compared to flexion extension motions. So I think we have to think about if we can really trust results from these video and retrospective studies. So what we have to do is to compare to other studies. And there is a good studies like cadaver studies and the study using living humans and computer simulation studies. And we need to validate the results of these studies to like retrospective interviewing studies. And this is an example of cadaver studies. And this is a study done by University of Pittsburgh group. And they use this kind of robotic arm. And this is cadaver knee from pigs. And they simulated 200 Newton quadriceps force and 80 Newton medial and lateral hamstrings force using pig knees. And this is simulating the quadriceps muscles force. And these two wires, these wires are simulating hamstrings force. And they calculated the amount of ACL loading with only quadriceps muscle force or quadriceps and hamstrings muscle force in the different joint angles. And this is another cadaver study example done by Eric and Dr. Holt. They applied in this study, they applied a compressive force to the knee until ACL is actually ruptured. And I was really impressed with his research papers because his study impacted our research area. ACL injury prevention research, because his research answers so many questions that we didn't know. So after his research, the direction of ACL injury mechanism research kind of shifted to what he was saying. So he did a really great job in understanding examining the mechanism of ACL injuries. So anyway, so this is another example of study using a living human. In this kind of in vivo studies, small strain gauge like this is attached to the ACL in the living human, and they made subjects to do different kind of exercise like step up, step down, lunges, those kind of things. And they measure the amount of strains. And this is another example done by Bienen. They also attached a small, strain gauge to the ACL, and they made subject to squatting exercise, and they, examined the amount of ACL strains as relative to the knee flexion angles, like this. And this is the computer simulation model studies. They modeled, like these ligaments and bones and muscles like this, and they estimated the amount of ACL loading during some kind of task such as drop landing or drop jump. And this is actually the combination of computer simulation study and cadaver studies. What they did, this is a study by Shin et al. From Korea. They validated their computer simulation model from the data, using a data from the cadaver experiments like this. And this is the guy who did these studies, and we met. I met him in last IOC World Conference in Monaco. We went to buy chocolate together for our wives. So it was really good, Okay, then the strengths of these study models in cadaver studies. This kind of study can measure actual ACL force. And it is easy to control environmental conditions as compared to a study using living humans. And also, it can actually apply load until ACL is actually ruptured. So this is really strong model, I think. And it can simulate or measure all tissue forces if you want. In vivo studies, this is really a great study because you can get actual ACL loading data from living human. And also this provides information about ACL strain during a variety of exercises, real exercises. And also it shows relationship between knee joint angles and the amount of ACL loadings. And computer simulation study, you can control internal force, external force, joint angles more easily. And also it is also possible to examine what in vivo or in vitro studies cannot examine. Then how about the limitations? In the cadaver studies, one of the limitations could be not all tissues are intact, and one study shows that if you remove all the joint capsule, you may get different results. Also, it is probably impossible or very difficult to simulate all tissue forces during actual motions, right, Eric? And also, a majority of cadavers are from old people. So probably, we don't know if the data from this cadaver study actually reflects, athletic populations, like young athletic populations. And study using living human. It is, again, really difficult to, measure all muscle forces and joint angles in all plane of motions. And also, subjects cannot move whole range of motions. For example, if you have a small strain gauge on your ACL, if you fully extend your knee like this, you will pinch the strain gauge, so you cannot extend your knees completely. And also, strain gauge can measure only strain in limited part of the tissue. For example, if you, usually people attach strain gauge on the anteromedial part of the ACL, but we don't know, like posterior, lateral posterior part of the ACL. So you may have different strain in the different part of the tissues. In the computer simulation studies, it is really difficult to reproduce, all the characteristics, orientations, shapes in all tissues, as those in real tissues. Or it is really difficult to produce individual differences. So this is a study done by me, I and Dr. Schultz. We did a systematic review, and I think this is probably the first systematic review that examined and proposed a hypothesis for mechanism of non-contact ACL injuries. So what we did was we predetermined keywords or combination of keywords to search scientific articles using PubMed from the 1950 to 2007. And we initially found 1,455 articles related to ACL injury mechanism or ACL loadings. Then we selected 45 articles based on predetermined selection conditions. So why we did these kind of things was, article selection are less biased if you have a specific way of finding articles. And also you can reproduce same results, Then theoretical ACL injury mechanisms were proposed by examining findings in variable, many different kind of studies. And I made like this kind of tables, like But despite the efforts that people try to understand the mechanism of injuries, there are some controversies. For example, you can find so many data to the editor, like fighting some researchers about mechanisms, and this one too. And you find same paper names like this if you go to PubMed, and this guy is saying what they are saying is not right. And I think this is a really great picture that in the last ACL retreat. Have you seen this? These two guys are were fighting about the mechanism of ACL injuries. But in this meeting, they kind of hugged each other. So I thought this is a really good picture. So I took picture using my iPhone. So now they understood. Like probably arguing is not productive or something. Okay, then let's go to the study that aim for ACL injury prevention. Okay, there are some kinds of ACL injury prevention research. First, what kind of ACL injury programs may be effective to reduce non-contact ACL injury rate? For example, people make athletes do like some kind of training, some plyometrics training, balance trainings. Then examine the injury occurrence rates. Also studies that investigate mechanisms for how this intervention leads to ACL injury prevention. And this mainly is like biomechanical studies, like I do. And these are based on the theories for injury mechanisms. So So now I'm talking about this part. So now first one, first research area, topics is like just this. So what intervention, for example, what kind of training, what kind of conditioning, what kind of orthotics leads to reduction of injury rates. But if you do only this kind of studies, you don't know, why, this training leads to reduction of injury, but others are not. So we also have to do like this kind of studies. Probably if some intervention works to reduce injuries, you are probably intervening or modifying some risk factors, and this modification of risk factor leads to some good neuromechanical control, and that influence, the knee loadings, then reduce, injury rates. Or you may directly intervene, neuromuscular controls, then goes to, good, pathway like this. So we have to know, the mechanism of these pathways. So if I look at this, we still have so many things that we don't know. And this is probably the most famous intervention studies. And what they did was they used 1,263 high school athletes, and they divided into 3 groups. One is experimental groups, consist of 366 female high school athletes. Then they have a control groups, consist of 463 female high school athletes. And other control groups consist of 434 male high school athletes. Then athletic trainer in each high school collected ACL injury occurrence rates. Then experimental group implemented some neuromuscular training, including like plyometrics training, weight training, those kind of things. Then they compared ACL injury occurrence rates among groups. I think this research design is very simple and looks maybe easy, but it's really hard, to intervene people, especially with this amount. We have to have so many amounts of people who has to intervene because, if your number of the subject is small, no injury happens. So it's a really great study, I think. So then we also have to know why some specific interventions would lead to reduction of ACL injury rates, and some are not. So we have to know what kinds of neuromuscular control changes happens after implementing certain intervention program. And also we have to know what neuromuscular controls or deceleration strategies may be safer, and how modifying risk factors leads to reducing ACL injury risks. And this is a study that I did. And what I did was we examined how sagittal plane body positions influence the relationship among lower extremity internal moment productions during single leg landings. Then I discussed implications for ACL injury prevention. And this is the study done by me and Eric, that together. What we did was we estimated tibial anterior shear force using the theory in the study by Eric and Dr. Hout. And in the risk factor study, traditionally people try to identify the factors that may increase the ACL injury rates. For example, bone alignments, characteristics, joint laxity, and sex hormones, and geometry of bones, neuromuscular controls. And now people are talking about, if these risk factors are collectible or, non-collectible. And also we have to know, if there is any cause and effect relationship between these risk factors and injuries. So this is an example of people try to identify what the risk factor of the ACL injuries done by London. What they did was they used 20 ACL injured people and 20 non-injured people. And they measured knee hyperextension, navicular drops, and foot pronation, sacrum inclination, those kind of anthropometric data. And they predicted ACL injured people using stepwise logistic regressions. And what they found was greater knee hyperextension, navicular drop, which is like flat foot, or foot pronation significantly predicted ACL injured people. And their hypothesis about their finding was if you have a greater foot pronation, that may lead to greater tibial internal rotation, and that leads to greater knee internal rotation, which is tibial internal rotation relative to the femur. And because knee internal rotation increases the strain of the ACL, that increases the incidence of ACL injuries. So that was their explanation about how foot pronation leads to ACL injuries, increased ACL injury risk. So this is what they are saying. You have an ankle joint here, talocrural joint, and also you have a subtalar joint here. The joint axis in the subtalar joint is about like 42 degrees in sagittal plane, like this. So this is kind of simple model to explain how subtalar joint works. So if you have like this motion of the foot, you must have internal or external rotation of the the shank also. So this is the good movie about if you invert or evert your foot like this. So you also have tibial internal rotation or external rotation relative to the foot. This kind of motion coupling must happen. So people try to examine this relationship between foot pronation and knee internal rotation. For example, McClay and Manal, what they did was they compared tibial internal rotation relative to the foot and the thigh, and also thigh in the runners with and without pronated foot or flat foot. And LaFortune, what they did was they compared the tibial internal rotation relative to the patella in the condition with and without foot orthosis that modify the foot pronation. And they used bone pins, so they, instead of putting the marker on the skin, they inserted the bone pin on your bones directly. So they try to measure the amount of knee internal rotation more accurately. And also my dissertation also examined the relationship between calcaneal eversion or foot pronation and tibial internal rotation relative to the thigh. However, no study so far has found the association between foot pronation and knee internal rotations. So, their theory or their hypothesis was not supported. People say that because you have a flat foot, you have more knee internal rotation. That's why you have more injuries. This kind of theory has not been supported. So probably we need to think about other possibility to connect foot pronation and ACL injuries. So it is really, really difficult to connect how these risk factors really influence injury risk. And some other people try to connect risk factors and injuries. And this is another example. In this study, they used 1,597 midshipmen from the United States Naval Academies. And this is a 2.5 years prospective investigation. And they collected anthropometric and biomechanical data and the patellofemoral pain syndrome occurrence rates, and also other injuries too. And they prospectively examined what kind of anthropometrics or biomechanical variables predict patellofemoral pain syndrome. And they made this kind of diagram to explain why this kind of risk factors leads to increasing injury rates. And this is a study done by us, Dr. Schutz. And this is called the VKLD. What this machine do is in the spine positions, it simulates weight-bearing conditions. And we measure the amount of tibial translation relative to the thigh. And now what we are doing is we try to connect how female sex hormones influence neuromuscular controls, and how those that influence the the risk of injuries. And this is another movie. And you can also apply like internal and external rotation, and also valgus varus knee loadings too. And we also have like this kind of data. And also cutting motions like this. So there is some challenge to understand mechanisms for how risk factors contribute to increase injury occurrence rates. I think the biggest one is significant relationships does not always explain cause and effect relationships. So it may be just a coincidence. And then, so what should we do? I think we need to do more intervention study to test, the hypothetical mechanisms. So we have to have some hypothesis about how, this risk factor, leads to, injury occurrence rates, and we try to modify, that risk factors, then see the, the results. I think it's really, hard to do those kind of things, not easy. And also, just let me talk about the task used in the lab experiments. And there are some conditions, what tasks we should, make subjects do, and what kind of tasks we should use. First one is subjects consistently reproduce similar motions and neuromuscular controls during the movement. Another one is it kind of simulates motions that often observed during the injuries. There is some limitations. We really cannot make subjects perform real dangerous movements. Probably IRB does not allow us to do this kind of tasks. The data we obtain from this kind of movement may completely be different from actual data. So we have to try think about different idea maybe try so many other things. So anyway, then now I just want to talk about what we do in our research lab. I just want to introduce this at the end. With this framework of injury prevention research, our main goal is, first one is to examine and clarify mechanisms of lower extremity injuries. and also to explore how and why lower extremity injuries are prevented. And also, I want to provide scientific knowledge to like athletic trainers, physical therapists, strength and conditioning coaches, those kind of people who actually practice about how injury can be prevented, or those kind of information. So if you think about like this kind of like simple models. Because knee is in between hip joint, ankle joint, and also trunk, so many other body segments. So we shouldn't think about only knees. So what we do is actually not focusing only the knees. So probably Eric is mainly focusing on this part, and I'm focusing on like this part. Yeah, from risk factors here, and I don't have a capacity to actually examine the stress on the ACL, those kind of things. So that's why our collaboration happened. And also, I want to focus on this part too. So this is the example of our studies. This is the one that I presented like 2 days later. What we did was we modified the amount of trunk stabilities. We did some intervention to enhance trunk stabilities like this. Then we looked at the how this intervention modify your lower extremity biomechanics. Sorry, this is Japanese. And because trunk function is probably really important when you think about lower extremity injury preventions, I invented this one, this machine to measure maximum core strength. And what this one do is this one does like this. So what this one is doing is there's a wire here. So as he pull this handle, wire pull your the lumbar supine and forcefully extend your lumbar. Then we measure the maximum tension of the wire. And this is another device to measure the maximum core strength. Actually, this was introduced by Zasrak before. So she tried to pull anteriorly as much as she can, and we measure the amount of strength. You can also pull this wire backward like that. So you can measure the strength of your back. So your sacrum is pinched like this. So you cannot move your hip like this. So you can truly measure the amount of lumbar strength. Now we are trying to examine what we are getting from this core strength measurement method. One is the one I made, and the Zasrak one, and also the Biodex one. This is, I think, traditionally, the method that traditionally used to measure core strength, maximum strength. And we found some, quite lots of difference in muscle activations. And also, interesting thing was there is no association among these measurement methods. So probably we are measuring completely different thing. So our current research about core is, what kind of training are the most effective in the enhanced maximum core strength or stabilities, and what factors influence the amount of increase in core strength or stabilities, and how trunk stability influence lower extremity biomechanics. So these three may not be connected to each other. However, if you look at this, the diagram, first one is related to this part, and second one may be connected like this part, and those kinds. So anything within this area is our research topics. So this is what I want to try to, I want to create in my research lab. We want to interconnect, practice, actual practice, and research, and also education. And this is our athletic training room, and this is a rehabilitation area. And we have a check-in counter here, and also this is rehabilitation area. And this is whirlpool area, and this is evaluation table area, and the back of this rehabilitation area, we have all research equipment like this. So in the athletic training room, we also have a lab like this. So we have a motion analysis system, and biodex, and EMG, and other equipments. So I want to connect actual practice and research more at the same time. And we measure alignment, range of motion, joint laxities. I just made this. I went to like Home Depot kind of shop and just made these kind of things. And also we also intervene athletes. To see, if intervention program really, actually, works. This is a basketball team. There are like 45, athletes, players in this team. And fortunately, we haven't had any ACL injuries for last like 3.5 years. And this is some example of how, people can be trained. So it looks like she's very weak. She's a volleyball player. She has almost like no muscle. Her leg is shaking. So it looks like very weak. But after 2 months later, she became like this. Oh, that's my daughter. Sorry. So she became really strong. After 2 months of hard training. I trained them really, really hard. And I will show in the ERIC class later that what I do to train them. And also, if you think about the ACL injury mechanism, you can safely do these kind of things, like single leg landing from 90 centimeter. So no injuries. And also, you can do like these kind of things. So if you think about the mechanism of injuries, you have no damage, with this one. Probably this is really bad for your back. So, and probably I really think that educating like athletes or educating coaches, and and also talk about this kind of things to athletic trainer is really, really important. And I think probably the most important thing is like, good communication and, good education, I think. Without this, probably no intervention program will, work. So I just want to talk about, finally, reductionistic study and comprehensive studies. And reductionism is an approach to understanding the nature of complex things by reducing them to the interactions of their parts, or to simpler or more fundamental things. I think this kind of approach is really important, but we need to do more comprehensive approach, or a multidisciplinary approach to understand how injury can be prevented. And this is just my thoughts about how we should think about to apply scientific knowledge to the real world. I think we should know broad area of knowledge first and then study specific things deeply, because we always have to evaluate things from many different point of views. And also, we need to have wide knowledge of wide knowledge to communicate with other specialists. So if it is really difficult to do a big thing alone, so you have to collaborate with others. So, but you have to have a language to talk to those other people. And also, I think it is really important to know what part of this area you are doing in the framework of your research area. And probably it is necessary to know the history and the overview of the research topics. And I think this is really hard thing to comprehensively understand what is going on in your research area. And also, I just want to say engineers are really important in our sports medicine field. So some of you hopefully are interested in kind of involved in our sports medicine area. Okay, thank you very much. This is my university. And my university is actually small. We have only 2,600 students. And the good thing is majority of them participate in some competitive sports. So if I want to have athletes, as a subjects, I can get those people easily. So I think I will work here until my retirement. Yeah, thank you.
Okay, so we're almost to 1:30. I think we have time for a few questions, but if you have to leave, then feel free to step in.
I just wondered about the data on the earlier slide. You said that this injury affects females more than males, and the rate was between 2 and 8 times. That seems like a rather wide range. It seems like we should know it better than that, to a more precise number ratio. I didn't understand it. It seemed like 2 to 8.
Yeah, probably, depending on the research, people report different numbers.
Welcome to biology, Tony.
It depends on the sport.
Yeah.
I mean, either they were injured or not. Are they boys or girls?
But it depends on the sport. So in basketball, it might be 6 times. In soccer, it's only 3. Swimming.
Okay, thank you.
Any other questions? Come on, one more question? Yeah?
So when the subjects come for the experiment and you get the data, so is there a particular order they have to go through, or just you can decide? Because it seems like sometimes when a person does one task, that can affect the data collected from the next task. So what is the order?
Order is actually counterbalanced. So to eliminate the order effects. Yeah.
So every subject goes through all the tasks. Every subject goes through all the tasks.
Yeah. Yeah, that's repeated measures.
Okay. So thank you once again.